Good morning. All right, audio seems to be working. I am back after a trip out of town, and so now I get to come back and start doing Rust things again. Of course, which means I need to remember where I was with Rust because it's been good almost a week since I was able to play and do these, and I haven't actually played with the language at all while I was gone. All right, so uh, I know that a bunch of you have been watching the VODs when I'm doing these, so thank you very much for watching, and continue please to leave messages in the videos in case that you have questions or you have comments about how I'm doing things wrong and can improve them and do them better. So today it looks like we're going to print the lyrics to the Christmas Carol, The 12 Days of Christmas, taking advantage of the repetition in the song. I guess what they mean is that we're going to use loops and potentially, I mean, they didn't really tell us, they gave us arrays. They have to be the same type, but if it's just like strings, that should be the same type. I think this should be fine. Print the lyrics. So I guess the first thing to do is maybe, well, we can create the project and sort of set that up. So here you are in Learning Rust. Let's go to chapter 3, and we're going to create cargo. What is it? New dash dash binary, and then I'm going to call it 12 days. And I should be able to do cargo run and compiles and runs it. Okay, perfect. And let's open this up in code. All right, perfect. You can come over here. All right, here is our main print line, our cargo toml. Okay, so this will be the basis of us creating our 12 days of Christmas here. There is an update, not right now. But this does mean that I need to go research what the words to 12 days are because I don't remember. So what is it? 12 days of Christmas lyrics. Sure. Okay. So, well, this seems fine. Why are these? This seems really odd that they've highlighted some of these and not the rest. Oh, right. And 12 Days of Christmas is where you do the new one and then you go through all of the previous ones too. So we'll have this, but this is going to be so on the blah day of Christmas. So when we have this will be like a repeated over and over again with the day being changed. And I think we could use, well, so we could use a tuple, or we can use an array. I think an array would be better because we know it's exactly 12. So we can just set it to be 12 of these. Let's go remind ourselves how to do arrays. Okay, so it's not a scalar type. Oh, come on, computer, you can do it. Arrays. All right. So this seems easy enough. Can we grow it as much as we want to? No, we should not be able to. It should be set. Yeah, it should be set in memory, exactly like in C. I think there was another one that we can grow as much as we want or not. And I think, was that the tuple or was that something else? I can't remember right now. But let's set this up. So we know that we're gonna want days, right? So let days equals, and I wonder if I can do this. So it'll be first, second, third. All right, I'm just gonna write all these in. Fourth, seventh, eighth, ninth, ooh, 10th, 11th, 12th. That looks horrifically wrong. I wonder if... I'm not going to worry too much about the spelling of this. Okay, so once we have that, we should now be able to access that with standard. What are you? Yep, okay, we're good. Now you're just complaining that I'm not using you over and over again. That's fine. So now I want to just print line, and let's just do days of like 4. So that should be the 5th day. So 1, 0, 1, 2, 3, 4. Yep. So we'll save this and let's go run it. 5th, perfect. So now we have this, so we can use this to sort of like set these days. I kind of want, is an array a type? Can I return an array in a function and just like go hide that somewhere? Or is it just array? Or maybe I just won't worry about it right this second. Oh, did they have like a type tree somewhere? I remember there was somewhere they had, oh, these are just the number literals. I would want a full type map, which I bet I can get in the documentation. So Rust array type. What is it? I just want to know what it's called. Primitive type array, all lowercase. So if I wanted to create a function, so fn generate days, we're not going to take anything in, and we're going to return an array. Okay. And then we're going to put this inside. which means that we can also return this automatically, I believe, right? And then this is going to be let days equals generate days. Boom, like that. Cannot find type array in this scope, but you're returning an array. Oh, is this not? Okay, so if I do let days, and then just return days like that, will that be better? No. All right, let's get the real error. Cargo run. Not found in this scope. Oh, okay. So I guess this is not the right way to say that I'm returning an array in generate days, because it was working with, like, you know, U32 when I was returning that, but apparently I'm guessing this isn't doing exactly what I think that it's doing. So just for right now, I'm going to put this back and just leave that in here. And then I will later figure out how to properly return an array from a function. But we know that this works, so we're going to continue on with this. All right, so once we have like this part, then we need this part. So on the blah day of Christmas, well, which to me, that's just a loop, right? And we're going to for loop through the array. And I do remember, I wonder if my autocomplete will do this, that I can for day in days, let's print line, and it's going to be, is it just going to be day? Okay, string, so this is the array, is not an iterator. Maybe try and call dot iter. Ooh, okay. So dot iter. There, that gets it to us. I forgot that we need that dot iter to basically have it go through here and do this, but we get the value of it dropped right in here. So that's super nice. So we're going to say, I'm just going to come out here and copy and paste our song. Hey, what did I do with my, there you go. Copy you. All right, on the, and then this is going to become that. So we're going to save. And run it. Okay, so perfect. On the first day, on the second day, on the third day. All right, perfect. Hey, bring me back to code. There we go. So we've got the very first part of the line in. And the next thing for us to do is now have these actual verses. So like we know that we want partridge in a pear tree, and then it's going to be a reverse back down. So I wonder, because clearly I could just create another loop, but start with the 12th day at the, well, I'd want to begin at the, the beginning and go through. So partridge and pear tree would be the first ones. That'd be position 0. And then I want position 1. and then position 0 again. So we're going to start with wherever we are at now and move backwards again. So it didn't show me how to reverse through an array. So let's see. I mean, I can just do a standard loop, but I feel there must be a way to do this. Okay, for x, and oh, I can pass the all right, perfect. So I can pass the just a reference to the array in this part. So that iterator is just returning a reference. Oh wait, it's not. An array itself is not iterable. The solution is to coerce the array into a slice by calling a slice method. If the array has 32 or fewer elements, all right, so what I really want is to look at for loops in Rust. So Rust for loop. Oh, this is the book. I want to get the index number. Can I get that? Oh, there, on ranges. Can I do that? Line number, line. Okay, so I want this type of thing. Let's try it. So instead of just days, we're going to do the index and then a day. And we can do the same thing here. We're going to have I, save that, and cargo run. No, did not like that. Expected string found tuple. Oh, interesting. Oh, wait, never mind. This one. Consider using a reference. Wait, does it require a reference here? What are lines? Oh, it doesn't have lines in this one. And is this an older version of Rust? This is Rust book 1, so that might be too old. Can I go into like the actual full documentation for 4? So that's the book. That's a blog post. That might be helpful. Oh, they have a for each? No, they're just saying what we could do. Iterators and iterables. I mean, because like clearly I can create a variable and track the index, but I would prefer it to give it to me if that's something that can be done. Oh, unless what I wanted to do was not days.iter, but passing a reference to the array days. I wonder if that would work. Consider using a reference I and day. Non-reference pattern used to match a reference. Consider using a reference and passing in a reference of the reference. And if I brought this back to dot iter, yeah, it's just the same problem now. It's like going back and it's like, well, you can't do that. We're not going to let you do that. So if I just do day, we're back to being good here, but I'm not being able to get the actual index. So maybe what I should search for is for loop array rust index. Aha, this is the actual documentation. No, it's a help thing. Oh, I could do dot length to get the length to do the standard for loop on it. I mean, this is for I element in array iterable mute dot enumerate. Not sure I like that one. I kind of like the I kind of like just using the length here and then using range. So let's try that. We're going to come back here and say for I in range, and obviously it's going to be 0 to, do I even need to give it the 0 if it's just range to the thing? I do. So from 0 to days.length. Cannot find, oh, I need to pull it off of, does it tell me where? No. Ooh, if I run this, will the error tell me where it is? Let's see. Not found in the scope. Oh, I was kind of hoping it would say, oh, it's on standard. Go grab that. I need to go find where oh, this doesn't use where range is. Okay, so let's do rust range. Standard ops operations range. Oh, that's interesting. That's uppercase. Is there a lowercase version? No, it doesn't look like it. So what I want is this standard ops range, start and end. This is going to be it's a struct. So it's essentially like what I would think of as an object. So I have to hand it start and end. And it's going to return, I guess, a tuple. Or is it going to be an actual range of it? Contains, don't care about that. index. All right, well, let's just try this and see what happens. Okay, so standard ops range. So use standard ops range. Then in here, so instead of days, instead of this, we're gonna have range, and we're gonna pass in a this structure. It's gonna have start, going to be 0, and end, and that's going to be days.lang. Incorrect close delimiter. Did I not close something? All right, now your unreachable expression. Expected function found structure range. Did you mean range? Oh. Is it just that? Expected value found struct range. Did you mean range fields? Okay, well, I did, and I put that in there, so you are not happy with that. I mean, the other thing is, like, I happen to know that this is 12 long, so... Oh, can't... I want to go back into the for loops. Control flow. Did it tell me in here how to do it, and I just forgot that I read it? Where's our for loop? Repetition with loops. Okay, so repeating code of loops, that's just a forever loop. We have a conditional while loop. Looping through a collection with for. So, while index. So yeah, there is this idea, but we don't want to do that unless... Okay, a for loop looks like this in code. Here we go. So element and a.iterable. We don't get the index. I guess we maybe can do the index of or something. We can find out how to do that. Here we go. Here's what a countdown would look like in a for loop. And another method we've not yet, oh, reverse. Reverses the range. Okay, so this is 1 through 4. That's all I need. I'm trying to do way too much crazy stuff. I just want to do this. From 0 to days.lang. Right? Why are you unnecessary parentheses around 4? I don't have parentheses around 4. Head expression. Wait, I don't need... You're telling me I don't need this. Okay, I guess I don't need that. Okay, so then print line, And so instead of day, this is going to be days of I. All right, let's see if this works now. There's a long way to get to our cargo run, and 0 through 11, perfect. So that's exactly what we wanted to get. And we now know that we can reverse this if necessary. So that'll be interesting. Okay, so we'll start off by just doing, well, I guess it's not really start off. Now we can move on to the second part. So we have this coming down. We have which one we're on, and we're going through this list of the days itself. But in our song, we now have these specific verses that get added in here. So let's copy these in now and put them into their own array. So we have let days, and then we also have let gifts, I guess. So partridge in a pear tree. All right, so let's just pull these all in. Oh, interesting. And so I should probably not include. Well, I can, because it would always work. Every single time I use 2 turtle doves, there is an and there. So I might as well just throw this right here. Three French hens is next. Four collie birds. Feels weird to be doing this song in April. All right, then the 5 gold rings. Six geese a lane. Swans then. Maids. Dancing. And leaping. Almost done with this. 2 more. Pipers. And drummers. Okay, so this gives us now our 12 that should match exactly that in length. And what we're going to do is take the index and say, okay, if we're on index 0 here, put the 0th. But then we're going to want to reverse back. So if we're on the 5th, like we're on the 3rd, let's say, so 0, 1, 2, 3, we're on 4th here, we play 0, 1, 2, 3, we do this one, and then we want to go back and do these ones again. Which just means removing like doing another loop and subtracting I down. And I think we can do that with range. So we have this, but then we're going to say what the thing is. So it's going to be another print line. And I think it's just the thing. So we're gonna have, it's gonna be gifts of I. And then we want to reverse back down again. So I think we can do another for loop. Want to do another for loop and pass and go from range backwards. So we'll do for, instead of I, I'm going to do j in, I think it's going to be I dot dot 0. And now let's try our print line. It's a macro. And let's try gifts again with I. All right, let's see if we end up repeating a 0. I may have to put some kind of iterator in here to make like an if conditional to make sure that if I is 0, we don't do this at all. Cargo run. Expected 1F found. Where did I fail to do that? For unexpected token 4. So didn't expect this to begin here. No, here. Missed semicolon right there. Let's try again. Unused variable j. That's because this should be j and not an I. Okay, so on the first day we got a partridge, and on a second day we got just 2 turtle doves and ooh. So it didn't play in. It's not going to that second for loop. Yeah, it's just doing these first ones. Also, I'm realizing that I probably want to put in some kind of new line in here, which I think is easiest just to do another print line, maybe with 2. Oh, that's a little bit too much. Just 1. Okay, but this gives me exactly what I want to look at. The only problem, of course, is that we're not repeating again. So this range is not doing what I think it's doing. So what I want to do right here is just try a range. It's not inside of this for loop. It's just on its own. I want to say for for 5, count down to 0, print line. Oh, it's count in. Count. All right, so if we get a countdown from 5 to 0, then it's like what I want to do works. It's just not doing. Oh, so it's not, it doesn't allow me to do that. So I need that reverse. I need to do it as a 0, 5 dot rev, and then that should work. Yeah, that works. So it's going to be 0 dot dot I. I'm going to wrap this in parentheses and do a dot rev like that. I'm going to get rid of that code. Save. Let's see if this works any better. All right, so first we get the partridge, then we get 2 turtle doves and a partridge and pear tree. So 3 is these 3. This looks like it's working. And that's the Christmas song. 12 Days of Christmas. All of them right here. And at this point in time, I can now remove off that index. I don't need it in this print line. So save that. And then we have our days and gifts. So potential ways to clean this up: have a function that that returns these, so it's not inside of the main. It's not too bad right now. We're just sort of like going through and repeating that, but for the most part, this is done. So I'm going to save this, send up you, and send up you. And we're going to be 12 days of Christmas song completed. And send it on up. So in the Learning Rust, this is now inside of the chapter 3. And I have the code for this linked in the description. So in case you want to go take a look at this, try it yourself, it is there. Just go take a look at the book and see what is next for this chapter. Print this. Oh, and that was it. It's 7:43. We got about 15 more minutes. 17. Yeah, about 17 to be exact. Okay, so understanding ownership. Ownership is Rust's most unique feature and enables Rust to make memory safety guarantees without needing a garbage collector. Therefore, it's important to understand how ownership works in Rust. In this chapter, we'll talk about ownership as well as several related features, borrowing, slices, and how Rust lays data out in memory. So yeah, I ran into problems with borrowing, sort of at least a little bit of borrowing when I was trying to do some of the example programs in the last chapter. So we'll see if we can like expand our knowledge on borrowing this time. All right, ownership. Rust's central feature is ownership. Although the feature is straightforward to explain, it has deep implications for the rest of the language. While programs have to manage the way they use a computer's memory while running, some languages have garbage collection that constantly looks for no longer used memory as the program runs. It's strangely written, but yes, I understand that. It's like, yeah, look for areas of memory that are no longer linked to by anything, like you've removed the any like links to it, and then just destroy it. In other languages, the programmer must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks at compile time. No runtime costs are incurred for any of the ownership features. Now that's interesting. I guess it's because it's doing it all at compile time. Because ownership is a new concept for many programmers, it does take some time to get used to. The good news is that the more experienced you become with Rust and the rules of the ownership system, the more you'll be able to naturally develop code that is safe and efficient. And keep at it. So yeah, this is the thing that I've heard like from other people is tough to sort of get used to and knowledge. But I do like the idea of being able to own, I guess, certain spots in memory. And it's probably like what parts of your code owns what. That's sort of a guess. I have no idea if that's actually correct yet. When you understand ownership, you'll have a solid foundation for understanding the features that make Rust unique. In this chapter, you will learn ownership by working through some examples that focus on a very common data structure, strings. All right, stack and the heap. And this is where Felix was showing us about stack and the heap, but we're getting to the official introduction to it here. In many programming languages, we don't have to think about the stack and the heap very often. But in a systems programming language like Rust, whether a value is on the stack or the heap has more of an effect on how the language behaves and why we have to make certain decisions. We'll describe parts of ownership in relation to the stack and the heap later in this chapter, so there is a brief explanation in preparation. Both the stack and the heap are parts of memory that is available to your code to use at runtime, but they are structured in different ways. The stack stores values in the order it gets them and removes the values in the opposite order. Okay, yeah, that's standard for a stack. This is referred to as last in, first out. Think of a stack of plates. When you add more plates, you put them on top of the pile, and when you need a plate, you take one off the top. Adding or removing plates from the middle or bottom wouldn't work as well. Adding data is called pushing onto the stack, and removing data is called popping off the stack. Yeah, that's standard for most of the stacks that I've used in other languages. The stack is fast because the way it accesses the data. It never has to search for a place to put new data or a place to get data from because the place is always at the top. Another property that makes a stack fast is that all data on a stack must take up a known fixed size. For data with a size unknown to us at compile time or a size that might change, we can store data on the heap instead. The heap is less organized. When we put data on a heap, we ask for some amount of space. The operating system finds an empty spot somewhere in the heap that is big enough, marks it as being in use, and returns to us a pointer, which is the address of that location. This process is called allocating on the heap, and sometimes we abbreviate the phrase as just allocating. Pushing values onto the stack is not considered allocating. Because a pointer is a known fixed size, we can store the pointer on the stack. But when we want the actual data, we have to follow the pointer. So one thing that I can't remember and I think that it's the operating system's job to sort of like allocate a heap area versus non-heap area. And because I think it's all just in RAM, in memory. And then what we're going to be doing is saying like, well, hey, if we don't know what this is going to be, or if we want to sort of if we want to like just store like a string, for example, a string in which we don't really, and by string I mean string, capital S, we can expand that in size. We can do things to it. And so that will be stored in the heap. But a stir or str is a fixed size. We know exactly how big it is. That's going to be stored in just standard memory, a stack of memory. Okay, think of being seated at a restaurant. When you enter, you state the number of people in your group, and the staff finds an empty table that fits anyone and leads you there. If someone in your group comes late, they can ask where you've been seated to find you. Accessing data in a heap is slower than accessing data on a stack because we have to follow a pointer to get there. Contemporary processors are faster if they jump around less in memory. Continuing the analogy, consider a server at a restaurant taking orders from many tables. It's most efficient to get all the order at one table before moving on to the next table. Taking an order from table A, then an order from table B, then one from table A again, and then one from B again would be a much slower process. By the same token, a processor can do its job better if it works on data that's close to other data as it is on the stack rather than farther away as it can be on the heap. Allocating a large amount of space in a heap can also take time. So I wonder if heap... So the way that like memory is set up in a computer is, I mean, they do try, I know the operating system does try to keep things together. And this is where one of the big sort of fun things with Microsoft Windows came in, because everybody would everybody would find that their computers were slowing down until they what was the command that everybody would do? It's been too many years since I've needed to run that, because they removed it in NTFS, but in FAT32 you would need to basically run through memory, take all areas of memory that were like should be together but were separated, and put them together and order it all at the beginning of memory. That would leave a huge amount of space at the end that you would now have available for applications to use. And now it speed things up, because you would have this giant area for heap use or stack use. Because if the operating system decides, and by operating system I mean kernel in this case, if the kernel decides that it wants to store, like if you ask for a heap of data or a stack, and it just gives you a random place in that memory, and there's a little bit ahead of it and a little bit after it and then another one. Well, if you ask for heap, it might actually be, well, you get a little bit here, a little bit here, a little bit here. But the program that when you create it doesn't need to worry about that, which now means it needs to jump all around to get at it again. And I believe a bunch of that is fixed in journaling, but I can't remember enough about journaling to know if it's actually sort of constantly moving things around to be more efficient. When our code calls a function, the values passed into the function, including, potentially, pointers to data on the heap, and the function's local variables get pushed onto the stack. When the function is over, those values get popped off of the stack. Okay, so this is where it's just saying, okay, every little bit of our function, including variables on it, references to other areas of memory, they're all added onto the stack. So all of the function stuff. So if we have multiple functions going on and not finished yet, they all get added to the stack. Keeping track of what parts of code are using what data on a heap, minimizing the amount of duplicate data on a heap, and cleaning up unused data on a heap so we don't run out of space are all problems that ownership addresses. Once you understand ownership, you won't need to think about the stack and heap very often. But knowing that managing heap data is why ownership exists can help explain why it works the way it does. All right, so we have enough time to go through this one, and then it'll probably be the end of the stream. Ownership rules. First, let's take a look at the ownership rules. Keep these rules in mind as we work through the examples that illustrate the rules. 1. Each value in Rust has a variable that's called its owner. 2. There can only be one owner at a time. And 3. When the owner goes out of scope, the value will be dropped. Interesting. So it's each value in Rust has a variable that's called owner. So if we have a function that owns certain variables, as soon as that function sort of is done, now all of those variables are out of scope, and so the values will be dropped. It sort of kind of feels like garbage collection, but that's clearly from my only like pure garbage collection mentality right now, I'm sure. I'm guessing that as I build a mental model of ownership here, I'm really going to start understanding the nuances of how it's different, and hopefully how I can use it in Rust here. All right. Well, since it looks like we're coming up to a longer section with code, I'm going to be wanting to work on this code specifically then. So I'm going to put variable scope. We're in chapter 4, 4.1. Let's go and add this. So here we are. Let's go into the README. So currently at chapter 4, 4.1, variable scope. we're done with these. I think I did create another. Didn't I create this one? Let's take a look what there was. Oh yes, generate the nth Fibonacci number. I definitely do that. Let's go find a link so that way, because I don't know what I was thinking. I put these into separate areas in GitHub, and I should have like just put them right in there. They're simple enough applications. So I need to nth Fibonacci rest. Get this link here. And we'll do nth Fibonacci rest. There we go for that. I don't think I need a dot there. Currently at chapter 4.1 variable scope. Okay, perfect. So save view. Commit-am before I forget, and updated where I'm at. What? I escaped it. Hold on. Let's just replace you with a double quote. There we go. Get push. All right, so the Learning Rust README has been updated with where we're at, and we'll continue this on tomorrow morning at 7 a.m. Mountain Time. I am doing this live stream every single weekday at 7 a.m. Mountain Time. I'm currently going through Rust. Once we finish this book, we'll probably be creating something with Rust, just sort of like to play around with it. And then maybe some other random things. This is primarily a sort of a spot for me to warm up my brain for the day, and I hope that it can also be done for you guys if you want to learn Rust right along with me. This is perfect. So anyways, thank you for stopping by, or if you're watching the VOD, thank you for watching the VOD, and I'll see you guys next time. Have a great day.